I've always loved math and wanted to understand how things work, and I come from a long line of engineers. My interest lied more in the theoretical rather than the applied, and so I sort of went in that direction. Started researching actually gravitational waves almost immediately and haven't turned back since. I'm Sean McWilliams, an assistant professor in the Department of Physics and Astronomy at WVU. Einstein had predicted the existence of gravitational waves about 100 years ago. He didn't think that it would ever be possible to find them, and so this effort that I'm a part of, LIGO, undertook this extreme experimental challenge to find these really minute signals. And apart from just verifying that Einstein was right, which is of course exciting, it gives us a whole nother way of looking at the universe. So we've up to this point only learned about the universe by looking at electromagnetic radiation from light. We started invisible and we've moved to radio, etc., but this is an entirely new and independent channel of information that we're gaining from these gravitational waves. So that's what's so exciting about it, this new way to do astronomy. The main source of gravitational waves, the only one we've seen so far, is pairs of black holes. So this is the end state of massive stars. So what we've seen so far are several pairs of black hole mergers. It's incredibly hard to capture these gravitational fluctuations, but the flip side of that is they don't get sort of messed up by everything in between us and the source that emitted them. So whereas light could leave a source and bounce off this and that and scatter off of this and change its nature fundamentally, just change the way it appears from what it looked like when it left the source, gravitational waves don't do that. They just travel on along and they'll go through anything in their way and they won't be disturbed at all, and then they'll reach us and we're now sensitive enough to see them. We know that light can't get to us from the earliest stages of the universe, but gravitational waves can. So in principle, if there are gravitational waves coming to us from the Big Bang, the earliest epochs of the universe, we could see that. It wouldn't have been absorbed by anything in between. When the discovery happened, I lectured the following day and told the students a bit about it, and they were very excited. But that's not just myself working on this topic. There's faculty in math, there's other faculty in physics. We have a large contingent of grad students in particular that are working on this topic. So I think the excitement has taken a marked uptick since this has happened, and we've drawn better applicants to our program and bright minds that are drawing them into gravitational wave physics, which is very exciting.